Hello, guys. It's Kumar K, your favorite DSA teacher. When it comes to solving hard unseen DSA problems asked in online assessment and interviews. So today we are going to solve a very interesting Google online assessment problem. It was asked on October 28th. It's a really difficult problem. And if you are someone who only focuses on standard DSA problems, standard algorithms, trying to memorize popular DSA sheets, you'll not be able to solve this problem because this problem requires very high level, problem solving skills, high level analytical skills. You need them for this problem. So what I'm going to do is teach you this problem in a brilliant manner, so you guys can also improve your these skills and crack good offers in the future. Okay, so before going towards the problem, the name of the problem, let's check out the name also. Like, this problem was asked on October 28th. Its name is network node optimization. We don't have the exact image, but from our students memory we know that this was the problem. Okay, I will share the constraints also very soon. Also, guys, whoever, like, if you are a beginner or an intermediate and want to master your DSA skills, for to crack top tech companies, online assessments, interviews. Okay, you want to go steps beyond the standard DSA stuff, and you want very high level DSA training, then you can check in the description. We have a special offer for the our Diwali and Happy Indian New Year. So you can check it in the description. We give daily live training when the new batch starts, one-to-one mentoring, 850-hour course, and referrals of top 500 companies. So you can check that in the description. Now, guys, let's start the enjoyment phase. Now we are going to enjoy. So what's the problem? Let's check it out. Let's check it out. So this is the problem. Part of Google's data network team, you are asked with optimizing a sequence of data nodes stored in a linear array to reduce redundancy. Okay, you have an array representing a permutation of data nodes. Okay. So, guys, problem is quite difficult. So let me make it a little bit easy for you. They are saying that you are given a array of size n. Okay, in this case, the size of the array is 4. You're given an array of size n. Okay, so I understood that. Great. But this array is a permutation of n numbers. I hope you understand what is the meaning of permutation of n numbers. It means that if n equal to 4, consider all the numbers from 1 to 4. Any arrangement of these numbers, any kind of arrangement of these numbers is called as a permutation of n. So this is a permutation. See, 3, 1, 2, 4. One possible arrangement of numbers from 1 to n, each coming for exactly one time. Okay. So you are given a permutation like this. You have to print yes if you can convert this array to size 1. Okay. If you can delete some elements and convert this array to size 1, you have to print yes. And you have to print no if you cannot achieve that task. Okay. Okay. Now your question must be, but sir, how can we, or bhaiya, how can we convert the array to size 1? So let's check that also. So what can we do is, I gave it here also. Yeah, given a permutation of size n, do a particular operation as many times as you want. Can you convert the array to size 1? What can we do in a single operation? Select any pair I comma j such that I less than j and bi less than bj, and remove either ith element or jth element from the array. That's it, guys. That's it. So they are saying that the array is given to you. Select index I, index j. If I less than j and the element at the ith position is lesser than the element at the jth position, you can remove any one of the elements. Do this operation as many times as you want. Can you make the array to size 1? If you can do that, then print yes, else no. So this was asked in Google online assessment, and now we need to demystify the secrets. We need to know what to do here. So let's think what to do. So always start with the simple cases, right? So in this case, what can I do? Think what can we do? I can select 2 and 4, right? I can select 2 and 4. This as my I, this as my j. The condition is satisfied. See, index I is coming first, then the index j is coming. Also, let's call this as the B array. B of I is also less than bj. If this condition is satisfying, you can remove either I or j. So 2 comma 4 is a valid pair. So let's remove 2. If you find a valid pair, you can remove that. So guys, what will this array look like after removing 2? It will look like 3 1 4. Now this is our I and this is our j. Again the question says, like this is now our 314, right? So again I select this guy as my I, this guy is my j. 1 comma 4 is also valid. Why? Because I is less than j and the element at I is also less than element at j. So this time either I can remove fourth number or this number 4 or number 1. I will remove this one. So it will look like 3 comma 4. Again I select this as my I, this as my j. I can remove any number because I less than j and 3 less than 4. Both conditions are satisfied. So let's remove 4. It will become 3. Even if I remove 3, it will become 4. But both are valid because both are of size 1. So the answer to this case is a yes. Okay. So lovely students, I hope that you understood how are we dealing with this problem. Thank you. Guys, we are going to analyze the brilliancy of this problem. So first observation is that if n is at the end of the array, answer is always yes. So let's quickly check why is this true. Let's say n equal to 5, a permutation of size n is given to us. The largest number is 5, right? It is at the end of the array. Answer is always yes in that case. Why? You can take any index. This will always, let's say this is my j. I can take any random number from this much part and call it as index I is less than j, obviously, because j is nothing but always what? J is always the last index. Okay, we are assuming. Okay, so j is the last index. This is, and all these numbers are less than 5 because the largest number is at the end, right? So 2 comma 5 is valid. You can delete 2, right? Delete it. Similarly, all I can take 4 comma 5. Again this is valid because largest number here, smaller number there, I less than j, delete it. Again 1 in 5 years, so again I take it, delete it. I take 3 and 5. Again 3 comma 5 is valid because why? 5 is at the end, so obviously its j is bigger and 3's I is less, and the values are also like this because 3 is less than 5 because the biggest value is at the end. So all got destroyed. So if the biggest value is at the end, we can see that answer is always yes. Similarly, if the biggest value is at the start, answer is never possible. Okay, it is never possible. You can check the reverse. Same goes guys for 1. If 1 is at the start of the arena, answer is again always possible. For example, let's write here 1. 1 is at the start, answer is again yes. Why? You can always fix this as I and fix the other guy as j. Yes, I less than j, 1 less than 5, delete it. Yes, select this as j. Yes, 1 less than 3, delete it. 1 less than 4, delete it. 1 less than 2, delete it. Okay. So I hope you understood that this basic observation which we are trying to do is that, see, if the largest number is at the end of the array, answer is yes. If the smallest number is at the start of the array, answer is again yes. Okay. So I have written it here. You can check it out. Okay. Done. Similarly, if n is at the start of the array, answer is never possible. You can try that for your own. Okay. Now, guys, in these type of problems, now whenever a single operation is given to you, and it is a type of inversion. What is inversion? Okay, we need to discuss what is inversion. Like this is a trick in the CP problems generally, that if they are saying that only focus on the operations such that I less than j and this less than this or something like that, and do those operations again and again, now the trick is that you can always make a graph out of it. You can always make a graph out of it. So what will happen if I try to make the graph out of it at this position? Okay, so the new idea is that If I less than j, I will run two nested for loops. Okay, I will run two nested for loops and I will create a graph. Okay, so one for loop, my I is going from let's say index 1 till index n. I'm using one based indexing. Next, my for loop j is going from I plus 1 till n. Okay, obviously I is less than j, right? If bi is less than bj, what will I do? I will create the edge. Okay, I will create the edge. I will create the edge which is going from node bi, okay, which is going from node bj towards bi, and then I will try to observe the graph. Okay, guys, so now let's observe the graph. So if I take the array 3, 1, 2, 4, let's start traveling from the end. If I travel from the end, I can see 4. I made the node 4. Then I come at 2. I see that 2 is less than 4, right? 2 is less than 4. So I will make the edge. I will make the edge from 4 to 2 because it is less. Okay, done. Then I come, 1 comes. 1 is less than 2. So edge, from 2 to 1. Also 1 is less than 4. So edge from 4 to 1. Okay. Then I come to 3. 3 is less than only 4. So edge comes from 3 to 4. This is a single connected component. Okay. So guys, the thing is that it is a single connected component of our graph. It is a directed graph, but you can, look at it. It is a single connected component. So what to do? The basic observation says that if there is a single connected component, one single connected component, answer is always yes. You can always delete this component smartly and reduce it to single node. How can you do that? Very simple it is. First, you can see the outlier 3 and 4, right? So let me write it like, let me show it in normal edges, undirected edges. So 3 to 4, then 2, then node 1, it's looking like this, right? So first I will select, see, I can, in one move I can select any edge because all the edges are valid. I select 3 and 4. This edge is valid, I delete it. Done. Then I will select, let's say 1 and 2 and delete 1. Then I will select 4 and 2, delete 2. So basically only one node is left in the end. Okay. So guys, I hope you like the brilliance. You see in higher level problems what happened. They gave us the array problem, but then we did the observation, and now we have converted to graph. And in graphs also, it's so much fun going on there. That's why I really love DS, and you should also love it. Not standard DSA, hard unseen DSA problems is where the real love gets created. So let's check. Now, guys, let's go through some other example also, right? To prove that if there is a single connected component after the creation of graph, your answer is yes. So yeah, it's a very interesting problem. Let's take one more example. Okay, 523614. 523614. I hope I am correct. Okay, so node number 4. Okay, then I come here, is 1 less than 4? Yes. So 1 and the node got created like this. Okay, the edge got created. 6, is 6 less than 1? No. Is 6 less than 4? No. So 6 is a separate node. Okay. 3, is 3 less than 6? Yes. So, but 3 is less than 4 also. So one more. 2 is less than generally all the numbers except 1, right? 5, 5 is only less than 6. So guys, if I try to now make this graph look normal, how will it look like? It will look like that there is a node called as 4. It is touching this node called as 1. This is touching this node called as 3. This is touching this node called as 6. This is touching this node called as 2. This is touching this node called as 6. Then this 6 is touching this. Guys, this 5 was here. Now I'm changing its location, showing it here for better visualization. Okay. So it's something looking like this, right? Yes, sir. It's almost looking like that. Now, guys, only single connected component it is. It is just a single component of graph. Single components means you can destroy all the nodes and reach just a single node. How? First, you will select 1, 4, 1 is destroyed. Then you will select 3, 4, 4 is destroyed. Then you will select 3, 2, 3 is destroyed. Then you will select 2, 6, 2 is destroyed. Then you will select 6, 5, 6 is destroyed. Only 5 is remaining. So I hope you understand that if there is a single component after the creation of graph, if there is a single component after the creation of the graph, the answer is always 1. Yes, answer is always yes. So let me show you. For example, this is a single connected component. But if I make one more two nodes like this, these are two components. If there are two components, na, answer is never possible. So let me show you never possible case also. Let's go to the never possible case. Okay, it's 453 612. 453612. Okay, so 2 is coming here. Great. Okay, 1 is coming. Okay. 6 is not less than any 1 or 2. Only check on the right hand side. So nothing. 3 and 6, yes, valid. 5 and 6, yes, valid. 4 and 6, yes, valid. 5 and 4 is also valid, na? Right, right, right. So 5 to 4 is also valid. But this answer to this is no. Why? Because you can destroy this component, you can destroy this component, but again here one node will be left and here one node will be left. Total two nodes will be left. In the end we want only single node. Why? Here I can destroy, let's say, 2, but still 1 is remaining. Here I can destroy all the nodes, but at least 6 or someone will remain. So 2 nodes will be remaining and the size of the array will be 2, not 1. Okay, so 6 will be here in the end, let's say, and 1 here will be here. You cannot perform any operation here. See, I and j. I is less than j, but 6 is not less than 1. So it's not eligible to perform operations on that. Okay. So guys, the solution is simple. See what kind of brilliant thinking and brilliant visualization solves this problem. Everything is totally brilliant. I'm loving each second of this session. So now, guys, the solution is very simple. That if the final graph has only one connected component, answer is yes, else no. So time complexity will be n square because I'm running two nested for loops to make each edge, right? Then I will, if a graph is having n nodes, n square edges, okay, in worst case, BFS will also take n square. So I will do BFS and check the number of connected components. If only one component, answer is, you know, yes. If more than one component, answer is no. So hope you also like that. Yeah. So how do we optimize it, guys? Optimization can be done using sorted set. So guys, optimization is the most brilliant part of the whole problem. Okay, so all we need to do is that we need to closely observe how this graph is getting created. Once we notice that pattern, we can use some shortcut to create this graph and get the number of connected components rather than creating the actual graph. So let's head towards success glory. Okay, so now let's use some special observations. Here I will travel the array from the end. Okay, this is 5, right? So I will write a 5 here. This is 4, but 4 less than 5, so one edge will come here. Okay, I'm traveling like this. Then comes 8, but is 8 less than 4? No. 8 less than 5? No. So this is a separate component. Now this is the separate component coming up. 7. 7 is less than 8. Okay, now 1 comes up. What is the speciality about 1? Till here, there are two connected components, 7 to 8 and 4 to 5. When 1 comes, what happens? Even 7 can join 1, even 8 can join 1. So basically, this guy can join this component number C1 also. But 1 can join the 4 also, right? Because 1 less than 4, 1 can join the 5 also. So basically, if all in all we try to observe, let's say we have two connected components, okay? We do have two connected components. You can see that we do have two connected components, right? So one will join this component also and one will join this component also. And after that, this will become just a single connected component. One is helping with the merging of both the components, guys. Did you get the point? That see what kind of brilliance is this, that as soon as जैसे ही वन आ जाता है ना हमारे क्या कहते हैं कैलकुलेशंस में, सो वो दोनों कंपोनेंट को जोड़ के सिंगल कनेक्टेड कंपोनेंट बना देता है. हमको सिंगल ही तो चाहिए था, राइट? सो इट्स ब्रिलियंट. सो वन इज नाउ क्रिएटिंग अ सिंगल कनेक्टेड कंपोनेंट. हाउ? मैं आपको लाइव प्रूफ दिखा सकता हूँ. This 4 was like this, 5 was like this 8 was like this, 7 was like this. Now comes a 1. What happens? This happens. Everyone is pointing at 1. Now this has become a single connected component. So guys, you can use a set and maintain all the components, okay? I will use a sorted set. And in the sorted set, there will be largest element of each connected component. Largest element of each connected component. Now guys, why am I only keeping the largest element of each component? Think. Pause and think that why instead of storing the whole component, why am I just storing the largest element of each component? What's the reason? The reason is that if you know the largest element, you can easily know that if you can join that component or not. For example, here there is 5, right? Here comes 4, right? But in my set, I will only store 5. I will not store 4. 5 is the largest element of this component. So in my sorted set is a data structure which keeps the numbers all in sorted format, and you can do insertion and deletion as you want. Okay. So now let's increase our focus. So 5 is there in the sorted set. Now here comes 7 and 8, so it looks like this. But I will not store 8 and 7. I will only store 8. The topper. I will only store the topper. Basically, for this component, which is the largest number 5, I stored 5. For this component, which is the largest number 8, I stored 8. Now comes 1. So in the set, just check which elements are greater than 1. 5 is greater than 1. 8 is greater than 1. It means 1 will merge them both. So 5 and 8, remove them from the set and merge them. Instead of 5, 8, just write a single 8. Because 1 ने सबको जोड़ दिया है. 1 7 से जुड़ा, 1 8 से जुड़ा, 1 4 से जुड़ा, 1 joined 5. अब इन सबका सबसे लार्जेस्ट एलिमेंट कौन है? 8. So only 8. So like this, you keep on doing the process till the end of the array, and if the final set has only one element, it means only one component was there. Okay, so such a brilliant problem. I really love this problem. I hope you guys can also see how your thinking skills are improving while solving this problem. How much you can think and how much further in life you can reach. You can see that here. So what's the final solution? Final solution is pretty simple. Pretty simple. Instead of maintaining different connected components, just maintain the largest number of each connected component. Okay, just maintain the largest number of each connected component. Travel from end to one of the array. Put the largest element of each connected component in set. Okay, if the b of I is greater than all the elements, then a new connected component with largest element b of I gets created and added to the set. Okay, gets added to the set. So, but if b of I is, let's say, less than equal to three elements of the set, it means b of I is less than three connected component topmost elements. It means b of I will merge those three connected components. So delete those three bigger numbers and then just put the larger number back there. And like this, you can maintain the connected components. Let's now see the final example and enlighten ourselves. So if this was the array, you can see 4 5 one component became, right, as you're traveling from here. Then 8 7 one component came, 10 9 another component came, 12 11 another component came. What to do if at index I 6 is coming? If 6 is coming, and guys, these are the scene, this is your set which you have made. The top, the biggest element of each component, biggest element of this component was 12, 12 is in the set. Biggest component of this biggest element of this component, 10, 10 is in the set. Biggest element of this component, 8 is in the set. Biggest element of this component, 5 is in the set. Okay, but now if I bring a 6, 6 will attack which component? 6 किसको attack करेगा? 6 will attack which component? Will 6 attack 5? No. अगर मैं यहाँ पर 6 लिखूंगा तो ये ऐसा एच कभी बन ही नहीं सकता ना, क्योंकि 6 5 से छोटा नहीं है. 6 will only attack the guys bigger than 6. So in the set, do the binary search and find out the elements which are bigger than 6. Sir, 8 is bigger than 6, 10 is bigger than 6, 12 is bigger than 6. So if I make a 6 here, 6 is going to attack here, attack this component, attack this component. So these three components will be joined and made a single component. So destroy them along with 6. 8 destroyed, 10 destroyed, 12 destroyed. All the numbers bigger than 6, destroy them in the set. Now, only replace it with the biggest number 12. Because guys, जब ये तीनों जुड़ जाएंगे ना, तो इनका सबसे बिगेस्ट नंबर कौन होगा? 12 होगा. और सबसे स्मॉलेस्ट 6 होगा, तो 5 और 12. दैट्स इट. ऐसे ही आपको एल्गोरिदम आगे बढ़ाते जाना है. जब भी एलिमेंट आता है, जस्ट चेक which numbers are strictly greater than our number in the set, delete all of them except the largest one, and that's it. And if there is no bigger element, then create a new component for yourself. So I hope you guys really enjoyed this problem. Ram 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 ram. Okay, so